Okay, so here we've got question 9 from the CWC test, and hopefully looking at that you're straight away recognising it as partial fractions, and the first part was generally done well on this question. So if I look at this identity here, I can see I've got x's in the denominator, so the first thing I want to do is multiply both sides by this whole denominator, and if you do that you should end up just with the 13 minus 4x on the left hand side and this expression on the right. And worth just pausing the video and just checking that you're happy with where all of this comes from on the right hand side. I then need to basically work out what the A, B and C are, and we have to remember that this is an identity. I've actually just written an equals there, really it should be an identity symbol there, and that means that this will work for all values of x. I can just choose values of x to substitute in and it will always work. So I choose values of x that are going to make some of these factors disappear, basically. I'm going to make them equal to 0. So the first one I'm going to choose, I'm going to make this bracket equal to 0, or this term equal to 0, so that means choosing a value of x of negative 3. And if I substitute that into the left hand side, x equals negative 3 into there, I get 25. If I substitute x equals negative 3 into the right hand side, well, this becomes 0, which cancels that whole term. This one becomes 0, cancels that whole term. If I substitute x equals negative 3 in here, that gives me negative 5, and then I square it and I end up with 25c. So I end up with this little equation here, nice easy equation to solve to find c, so c clearly equals 1. So you'll get a method mark for substituting an appropriate value of x, and then an accuracy mark or a B mark for your value of c. I can then do exactly the same and make these brackets equal to 0 by substituting in a value of x equals negative a half, and in a similar way that cancels this expression and this expression and just leaves us with b into, and it'd be 5 over 2 if I substitute negative a half in there. Do the same to this side, substitute negative a half over there, I get 15. So I end up with this equation here, which I can solve again to get b equals 6. To find a, it's a little bit trickier, but I can do it by thinking about the coefficients of x squared, because if I expand this, I will get 2ax squared. So I'm going to look at my coefficients of x squared on this side, then I end up with 0 x squareds, so my coefficient is 0. As I just said, this expression would give us 2a x squared, so coefficient of 2a. This has got no x squareds. This expression, if I expanded it all out, would give me 4c x squared, so coefficient of 4c. So I know that this equation must be true. I've already worked out what c is. C we know is 1, so I can substitute that in to just get 4, and that allows me to nice and easily find the value of a as negative 2, and that would give you your final accuracy mark. We can kind of check our different version of the expression. We can do it just by substituting in any value of x into this side, substituting it into this side, and check that it comes out to be about the same. So I've just chosen a value of x as 7, substituted it into the left hand side, it gave me negative 1 over 50, then substituted it into the right hand side, it gave me negative 1 over 50 as well, so it would suggest that those two expressions are the same. For part B, we're asked to integrate that function, which is the same function we've just been working with. So it's got the word hence. We're going to use what we've just found out in A, so we can rewrite that as the integral of our partial fractions. And I've separated them into 3 separate integrals. So I'm going to just take each one of these in turn. So I'm going to integrate this one first of all. It's almost in the form where the numerator is the derivative of the denominator, but the derivative of the denominator is 2, so I've just taken the negative out. So now it is in the form where the numerator is the derivative of the denominator, and hopefully you're happy that when we've got it in that form we can say the integral is just ln, natural log, of the denominator. I need to keep that negative there, so it ends up being negative ln of 2x plus 1 plus some constant. Okay, then for the second integral I can rewrite it in this form here, and for this one I'm going to use GDA, guess, differentiate, adjust. So what I'm going to guess is 2x plus 1 to the negative 1, 1 power higher than that. I differentiate this function and I get negative 2 outside. Well, I don't want negative 2 outside, I want 6, so I need to multiply this by negative 3, so that when I differentiate it, it would give me the right thing. Alright, so that's my adjustment for that one, which tells me that the integral of this one is negative 3 into 2x plus 1 to the negative 1, and again plus some constant. Then on to the third term. Well, the third term is already written in the form where the numerator is the derivative of the denominator, which means straight away I can just write it as ln of x plus 3 plus some constant. And then I just need to make sure I put it all together. So we can say the integral of the whole expression is this term here plus this term. Well, it's negative, so I've just minused that term, plus this term here. The c's, I can just collect all of those together. They're just constants that we don't know what they are, so I've just put one constant at the end. And that's it for that question. Thank you.